We can get started. Thanks all for coming to today's seminar, which is the Faculty of Information Technologies and also in collaboration with the Digital Education Research Group from the Faculty of Education. It's my great pleasure to introduce today Rafael Ferreira Mello, who comes from Brazil. Rafael is an assistant professor in artificial intelligence there. I had a great pleasure to work with Rafael for more than 2 years now. We started working together when Rafael joined us as a visiting postdoctoral research fellow at the University of Edinburgh. And then a few months later, I told him, well, look, Rafael, I'm moving to Australia. So I said, well, he always has this kind of positive Brazilian attitude. He smiled and said, well, that's a good opportunity, so let's continue working together. And so Rafael is doing lots of interesting work in natural language processing. His past work was related predominantly to text summarization, but over the course of time, he actually started focusing more and more on education. So he's done some work in the past also on plagiarism detection, but today he's going to be talking about research he's doing on analysis of online discussions from different angles. In my view, this kind of work that Rafael is doing is finally kind of pushing the limits in the ways how we are analyzing online discussions that has a very sound theoretical meaning when it comes down from educational research, at the same time also is offering us lots of practical insights. So, Rafael.
Thank you. Thank you very much, Dragan, for the introduction. And thank you all for coming today for my talk. I will try to keep it short so we can have a discussion after that. But I will also try to talk about everything that I've been doing the last 2 years. Okay. So the title of my presentation is Understanding Student Interaction in Online Discussion Using Natural Language Processing. And I'm analyzing online discussion, but I would like to analyze this discussion on the perspective of learning analytics. So that's why I'm going to start the presentation by remind you what is the definition of learning analytics, and it is the measurement, collection, analysis, and report of data about learnings and their context for the purpose of understanding and optimizing learning and the environments in which it occurs. For my presentation, I will highlight a few things. So as you saw in my title, I have the understanding, so it's very connected to the learning analytics definition. Also learners, I have students in my title. And what I want to do with this online discussion is to measure, collect, analyze, and report the data of these students. So during my presentation, I will come back to this definition a few times because it's very important for my work and my purpose. Just to give a brief motivation, nowadays, we are facing a context where online learning has become very popular, and more all the universities around the world are reaching this new way of delivering content for students. And in general, all the universities also have what they call LMS, that is the environment to share the resources with students, but also to help them to interact with each other and with the instructor. And there are several resources that you are probably familiar with, for example, assignments and content sharing and all the others. But today I will be focused on this resource up here, that is discussion in forum. There are several works in the literature that says that this kind of resource is the one that provides the higher level of interactions between students and instructors and between students themselves. So I just cite one of them, the last one that I found. But it's very clear in the literature that online discussion is where you can share your personal feelings, but also content and everything else. And I just included this figure to show how heterogeneous can be online discussions. So there are people from everywhere, and sometimes it's hard to instructors and all other people who is interacting with instructors, but also students to follow up everything that is happening in these discussions. So in this point is where my work goes. I will try to make sense of all of this and help both students and instructors to understand what's going on in these online discussions. Before I talk about my work, I brought two examples of different research that try to analyze online discussion, and I want to show a similarity between them. So basically, in one side, you can see here a lot of different graphs and analysis, but more related to statistics, and even this one in the middle is related to sentiment analysis, but they are just showing how many messages have some positive or negative sentiment. So it's just countings. And on the other side, this big circle is about the main words of the text that is showing up, the students are posting in the forum. Another example is this one. Here in the middle is graph that shows the relationship between students where they are replying each other questions or messages. And again, in this side here is just the main words and the content that is shared in the online discussion. And my point here is that so far what we've been seeing in this field is we extract these statistics and we show to students and instructors, but it's hard to make sense of them, and they don't really present what is happening in the discussion. They just have some indicators, but they don't address the content itself. Okay, and I like this figure because this is a kind of summarization of the learning analytics field. And in general for us, I'm a computer scientist, so in general for us, that has a background in this technology and computer science, we are very focused on this data science part of learning analytics. So we are trying to use different methods with different data and try to correlate the results with outcomes or with dropout rates. But it's not usual to connect with educational theories. Okay, the course design may be more up to the instructor who is running the course, but as researcher we can do both, analyze the perspective of the data scientist and also the educational theories and try to connect them before propose our application. In my case, as I'm working with online discussion, one educational theory that is very related to this kind of understanding interactions between students is the one called community of inquiry. And this theory says that a good educational experience, to reach a good educational experience, the discussion should have three dimensions. Two related to students, that is social presence and cognitive presence, and one related to how the instructor interacts with this online discussion. I will be focused on these first two that are related to the students, and I will give briefly an explanation of them. Social presence basically try to analyze how the students interact with each other in the discussion forum. So, for example, the affective dimension is if they are sharing emotions or if they are using some kind of sense of humor during their messages. The interactive one is the most common one. When you ask a question, you will answer a question, you continue a thread, and everything else. And finally, the last category is cohesive, where the students start to create this sense of group in the messages. And so social presence is divided in all of these indicators. And cognitive presence, which is the most important for me, is divided into 4 phases. The first one, that is the diagram phase, is when the students start to ask questions or the teacher posts a problem in the discussion. And then the students move to exploration when they start to answer this question. And a traditional online discussion could be just between these two phases with questions and answers for that questions. But this theory says that we should reach higher levels of cognitive presence by integrating these answers. So when the students start to connect different answers to create new concepts, it's called integration. And then when the students start to apply this new concept to their real life, so to give a real life example, it means that they reached resolution. So to have a good cognitive experience in online discussion, this theory says that we have to go from phase 1 to phase 4. It means from triggering to resolution. Not to jump between them, but go from 1 to 4. Okay, so my work is based on this theory and mainly in these two presences that I just explained. To analyze this kind of presence, this model, communicative inquiry model, over the years there were several approaches like manual coding, self-reports, automatic algorithms to code these different presences. However, all of this coding still leads to counting. So if you just use this approach, you will just have several statistics and you could show to the teacher these statistics. But it's not enough to understand what is happening in the online discussion, because in general online discussion is more dynamic. So it's not only about different indicators, but also about the relationship between them and how you can make sense of them. In this case, for example, I have the indicators of cognitive presence, the indicators of social presence, but also topics that are being discussed in the messages. And the whole idea of my analysis is to try to make sense of all of them and also the relationship between them. And to do that, I'm using this theory called epistemic frames, where this theory was proposed by David Sheffer, and basically it is operationalized by what he called epistemic network analysis. But the whole idea of this theory is to have this, not only the analysis of what codes we have and what topics we have, but also the relationship between them. I will briefly explain this theory for you, but if you have more questions, I can give more insights later. So this is an example. I really recommend this paper if you want to understand more details about this theory, because it's very practical. And basically, to use epistemic network analysis, we have to define three things. One, it's called unit of analysis, is what we want to analyze. It can be the student, it can be a group of students, it can be an activity. The conversation, and also called the stanza, is related to what we want to analyze. So, for example, in this case, we could want to analyze this unit column, that is group of students, and we want to analyze it regarding the text they are posting in the discussion. Okay, and for this, to analyze this text, we have to define codes. These codes can be previously defined, but we can also define it while the discussion is happening. So basically, we have to define these three things to use epistemic network analysis, and the output will be basically graphs like this. So on the right-hand side, you can see different networks where you have codes. So it's the same codes that we have here, if you see. So e-data, e-design, engineering. If you come here, you will see that it's the same codes that we have here. And we also see the relationship between the codes. So instead of just have the codes and the frequency of them, we have these connections and relationships. And these two networks that are shown in this right-hand side are the mean networks of a group
two different groups of students that is shown in the left-hand side. So in this case, the example have the group blue, the blue group, and the red group. The blue group is a group of students. Each node represents a student, and the square is the mean of this group. And each one of these students has a representation in one of these networks. So basically, it means that students that are in group blue, in blue group, they have more connections in the upper part of the graph. So as they are more in this part of the graph, they have more connections here, more strong connections, while the red group is in the bottom part, so red group has more connections down here. And this is how we analyze our data using disseminate network, and this is how we want to provide more insights for the instructors and for students on what is happening in the discussion. Okay, so today I will be presenting the results of these three papers. The first one, we analyzed the relationship between cognitive presence and course topics. The second one, social presence and course topics. And finally, the last one, the relationship between cognitive presence and social presence. Before we go to the analysis that I did, I will just explain the course design and the data that I have. It was a master course, a fully online master course in software engineering. So here's the topics of the course. We can see basic topics of software engineering. And on the right part of the, oh, I'm seeing the opposite here. So it's the left part for you. This is the course statistics. And basically the design of the course was a group of students had to design, not the course, but the online discussion. One group of students had to read a paper about the topic of the course, and then they prepare a presentation, post this presentation on the YouTube, and then the discussion goes about this presentation. And the students who had prepared the presentation was called experts, and the other students of the course was practicing. So the experts were in charge of the discussion over that week, and the practicing was asking questions and suggesting improvements to the presentation. And from the data that we have, it has 6 offerings of this course. For the first 2 offerings, there were no intervention at all. So the instructor just asked the students to prepare this presentation and post online and then start the discussion. But then for the last 4 runs of the course, the instructor prepared a document explaining this idea of cognitive presence, social presence, and how to reach higher levels of cognitive presence. So this is the difference between control and treatment group. And just to give a little bit of statistics, but I will go very fast on this part. But we have, as I just explained, control group and treatment group. And this first table is the numbers of messages for different categories of cognitive presence. The second one is for social presence. And we also divide it into expert and practicing, as I told you before. But just to give an example on what I don't want to see here, is just this. If you look at these numbers, you will see that from control group to the treatment group, there were improvement in the number of messages for, let's see, 29 messages for expert in phase 4 and 101 for phase 3. And then we have here much more, the number of messages increased a lot, and also for the practicing group. So it means that with the intervention, the students started to have more message related to phase 4 and phase 3. But it's just numbers. We don't know what's really happening inside these messages and this discussion. And as we are investigating topic, at this point, we are investigating cognitive presence in course topics. I have to say how I extracted the topics. I used this LVA method. It's a statistical method where you, based on a set of documents that you have as input, the model generalizes several generic topics. So basically we had all the message as a document, and we used the LVA to generalize generic topics. And then we matched these topics that was generated with course content, and we created our 14 topics model. And then we can apply this model to extract the probabilities of different messages belonging to different topics. Okay? So for the first paper that we published to analyze cognitive presence and topics, we have for the topics, as I mentioned, we extracted 14 topics related to the course content, but also an extra one related to course logistics. And we use as input for our epistemic network analysis students as unit of analysis. It means that we want to analyze the students. And we also use students as conversation. It means that we are using all the messages from the same student to analyze the connection between the different topics. And we use both course topic probabilities and cognitive presence as codes in this case. And with this input, we generate a few graphs. These graphs, one thing that I forgot to mention is that both of these graphs are projecting the same dimensional space. So we can basically compare both of them. You can put one above the other and see what is happening with the students and the relationship between the topics. So we can see here, there are two things that is important to analyze in epistemic network analysis. One is the size of the node. So if you go, you see this yellow plot here, you will see that the nodes related to exploration and integration are much bigger than the other ones. And you also see that this topic in the upper part was the most important one over the discussions because it has the bigger size of the node. And also we can see that if you look at closely, it's a little bit tricky here, but the connection between tigering and exploration is stronger than the connection between exploration and integration. For example, it can mean that it's easier for students to go from tigering to exploration, but it's harder to move from exploration to integration that is in the other part of the graph. And also, if you combine both graphs in the analysis, you will see that the blue group here is the treatment group, so the students that had the intervention, and the red group is the control group, the student who didn't have the intervention. So you can see that in general, the blue group is on the left side of the graph. So the blue group in general are here, so they are closer to integration and resolution than the red group. And we can get more insights when you see the networks of the different groups. So this is the mean network of the control and the treatment group. And we can see that very clear that here in the control group, the strong connections are more in this side with closer to exploration tigering, while the treatment group has more connections closer to integration, but also in general the connections among all of the four phases of cognitive presence are more well distributed than the ones from control group. We can also plot both graphs together, and it's easier to see the differences between these two groups of students if you plot all of them together. So once again, blue connections are the connections that are stronger for treatment group, and red connections are the stronger for control group. And we can see here that treatment group has more relation relationships with topics and cognitive presence in the higher levels of cognitive presence for integration and resolution, for example. And moving on, we have the second paper where we analyze the relationship between social presence and course topics. And we also use the same setup, but instead of cognitive presence, we included here social presence. And we got graphs that were also interesting, but if you can see now, the difference between control and treatment group is over X, Y, not over X, X, like the other one. So basically, the difference between the groups now is more related to different topics than related to the social presence here. So it doesn't mean that they had different relationship between social presence, but it means that the difference was not statistical relevant, significant. It was more, the main difference was just across the topics. And we also have the substructure, the mean networks for different groups. And you can see that the blue group have more strong connections in this part, while the control group in the upper part of the graph. And if we put them together, we will see more clearly the differences between them. So at this moment, I'm showing you like differences between these groups, but you can imagine this for different students, the individual students, and you can imagine how you can provide insights and feedback for this student based on the connections that they are making or not making. Okay, and the last paper was about the relationship between social presence and cognitive presence. So we have the same setup for ENA, but this time we don't have code, we don't have topics, we just have both social and cognitive presence as codes. And as output, we have, I first just introduced this graph because it shows that tigering is right here in the middle, exploration down here, integration and resolution are very close to each other. So once again, over the X, Y is kind of, if you project all of these phases to the XY, you will see that over the XY, it represents this cognitive presence. And for X, basically this node here is the one that has the stronger influence. So basically all the students that were plotted in this left part of the graph were the students that were more asking questions and don't doing anything else. And we analyze here again control treatment group, but for this one we also analyze practicing and expert groups. And you can see that experts that are showed as red group, they are more close to resolution, integration, but also emotions and humor that are related to the affective category, and also cutting messages from other users. So it means that they are somehow leading the discussion, while the practicing group that are giving suggestions to the presentation, they are more close to asking questions and the tigering, so, and salutation as well. So it's possible to get more insights on how what the groups are doing differently for each other. We also analyzed treatment and control group, and once again, treatment group was plotted in the part of the graph that is more related to integration resolution, while control group is in this part down here that is more related to exploration, basically. And for this study, we also plotted a different graph that, in my opinion, is the most interesting one, that it's called trajectory graph. So basically, we are analyzing how different groups of students were developing the discussion over time. And the discussion in this case was happened over 4 weeks. So, for example, we have this red group is the control group, the experts in the control group. And if you, once again, we can plot one graph below the other one, so we can use, they have the same dimensional space. So we can use both of them to analyze the results. So basically this red group were trying to reach resolution as soon as possible. So from week 1 to week 2, they were in the middle, and then they tried to reach resolution. While if you see the blue group, for example, they were basically going from tigering to exploration, and then referring message, and then tigering again. So they were in a loop between asking questions and answering questions, but they just stay in that part of the graph. So this, by the way, this blue group is the practicing for control group. So control group was on one side the experts trying to reach resolution, on the other side the practicing basically in this loop between asking question and answering question. It's kind of what happens sometimes in educational discussion. So the teacher are trying to help the students to reach higher levels of cognitive presence, while the students are just asking questions and answering questions. And the other two groups, they have some differences, but they kind of have this initial phase close to the middle of the graph. And then for week 4 especially, they are trying to reach higher levels of cognitive presence. So this is one of the most interesting graphs that we have that shows a lot on the behavior of the students over the online discussion. And I also like to always cite this paper in my presentation and also in my papers, because we have to be very focused and don't forget that learning analytics is about learning. So I just show you a lot of graphs that is very interesting research-wise. So I got a lot of insights from these graphs. But what kind of graph could be useful for teachers in the practice? We still have to answer this question with more details, but I think definitely this graph could help teachers. And also, if you extract the networks for individual students, so far I just show you networks for mean groups of the students. But now I'm showing networks for individual students. And we can see, for example, the purple one doesn't have connections in this part at all. While this green one doesn't have connections also in resolution integration and a few social indicators. So you can see that it's very clear the difference between students, and depends on what you are analyzing. You can send feedback for the student based on this graph. You don't have to read all of his messages, but you know it's like a summary, a graphical summary of what the students are doing in the online discussion. I also have here one student that is in the very middle of the graph. So you can see that he has connections to all of the nodes. Not all of them, but this one is more in the middle, so he has more connections among different indicators that we are analyzing. Okay, so we have all of this, but I don't know why it's this red sign stick to it, but no worries. Okay, we have all of these indicators, but we had manually coded data, which is good to analyze, good for research purpose, but it's not practical to ask teachers to code all of these messages for the students and then use this to analyze. So we have to somehow automatically extract this cognitive and social presence. And the cognitive presence, we have a huge literature in this. Initially, the methods proposed were based on word frequency and dictionaries. For the ones who works with natural language processing, you know that this is the most basic approach to classify texts. But the final result was not too bad, 0.31 of kappa. And in 2014, there were another approach that also used a bag of word approach, but not only with word frequencies, but also with n-grams and POS taggings. And this paper reached a better result, 0.41, but it also posted a problem of this kind of analysis because by using n-gram and part of speech taggings to classify this just small line discussion, the authors found like 20,000 different features. What it can mean? It means that you can have a very good classifier, but a very specific to one domain. As you are using just the words of this domain, in our case, software engineering, you will probably build a classifier that works only for software engineering, not for other contexts or even other language. And then a follow-up paper of the same author proposed to use, instead of the word frequencies or bag of word approach, use these different methods to extract statistics from the text. So this cometrics, Lewick, name entities, discussion context, it is methods that tries to extract the structure of the text, not the content itself. And with this method, the authors reached 0.63 of kappa. Just to give idea what these features are about. So Lewick, it provides several indicators of psychology process like affective, cognitive, social, perceptual. Cometrics provides features related to text coherence and complexity. And these discussion context features are features related to the structure of the discussion itself. So number of replies, if a message is starting a new discussion, or if it's just replying some message before. So yeah, basically these are the features that the state-of-the-art algorithm use now to extract cognitive features, cognitive presence. And okay, that's fine, and it was applied for English, but I'm from Brazil, so I'm just use this slide to say that for people who work with natural language processing, we have a huge problem, because if you change the language, it changes everything in the analysis. And as I'm from Brazil and I want to use this approach with my students, I have to create something for Portuguese. But hopefully I use the same approach, and the results was also very good. So I developed a classifier using the same features. Not actually the same, because the tools for Portuguese didn't have all the features that they have for English. So for example, Cometrics has around 100 features for English and just 30 for Portuguese. But even though the result we come up was 0.72 of kappa. Okay, that was good. And now we had a classifier for English and a classifier for Portuguese. However, we start to wondering how generalizable this approach is, because at the moment we just create the classifier for English and apply for the same data set. So the classifier was built on software engineering and we applied for software engineering. So what we did here was to try to combine Portuguese and English in the same classifier, as we are not using the words, we are just using this structural information. And we had to reduce all the English features to just the one that we also have for Portuguese. And by the way, the data are very different for each other. So the English data is a software engineering course, it's a master course, it's completely online. And the discussion was about that video activity that I just introduced you. And my Portuguese data is about a course that is related to biology. So it's completely different from computer science. It's an undergrad course, it's not a master course. And the discussion was about problems that the instructors start the discussion with this problem that the student have to solve this problem over the week. So the context is different. The methodology, the design of the discussion is different. And also the language is different because one is in English, the other one is Portuguese. But when we try to create the classifier in Portuguese, we use the same features and we train the classifier using Portuguese and test in English. We reached 0.69 of kappa, and the other way around we reached 0.75. So with these results, we still have to run more analysis, but we make posts now that this methodology to create this classifier is generic enough to be applied to different contexts, to different course design, and also to different languages. And it still works, and works very well. Regarding social presence, we haven't found any classifier in the literature. So we start to develop our classifier using the same methodology. And there is one thing that is different from social presence to cognitive presence, because for cognitive presence, we just have one class per message, while in social presence, we can have more than one. So instead of create just one classifier to identify social presence, we create 3 binary classifiers. So basically, each one of these classifiers says if the message belongs or not to one of these specific category. We reach the reasonable results, but we got these results and we applied the epistemic network with the same parameters, but in one hand, we will have the manual coded data, on the other one, the automatic one, and we reach the results very similar to each other. You will see the graph is flipped, but this one is the manual graph generated. By manual graph, I mean the graph generated with the manual coded data, and this other one was the graph generated by the automatic coded data. And you can see that it's possible to see, we still have to run some statistical analysis between this graph, but qualitatively speaking, it's possible to see that if you flip the graph, you will see, for example, that these 2 codes are here, while they are also here. Cohesive and interactive presence is slightly below the axis X, while here they are slightly the upper part of axis X. And it's possible to see that is very similar to each other, but the best part for me is the projection of students. So here are the students, and once again, this side is the manual, while this other graph is the automatic one. And we can see that the graphs are very similar. The students were not plotted in the same point, but they are very close to the points that originally they were. For example, all of them here here. The difference between the control group and treatment group, it's very close to each other. If you see, let's say, these other two here, down here. So the graph keep the main properties, and also when you compare different groups with the subtraction network, we can see that manual, automatical one, we can see that for the manual one, the control group has more connections in the upper part, while the treatment group in the bottom. As the graph is flipped here, we can see the same property, but just the other way around here. And even we also test, we run the statistical tests to compare two different groups, so the control group and treatment group, the blue group and the red group for both cases. And we can see that even the effect size of these different groups are very close to each other. So now our idea is to also have a similar analysis for cognitive presence, and then try to build all of our models, but completely automatically. Next steps, just to conclude my presentation. For those who are in computer science, you could be interested in these three following works. The first one is evaluate the social presence classifier for different language. We already did it for cognitive presence, but not for social presence. We are trying to run some optimization in the classifiers. So far, we had an improvement of 5% in the numbers that I just showed you by balancing the data. The data is very unbalanced. So we are using algorithms to balance the training data. And we also want to extract the social indicators, because we are just extracting the classes, social classes. But for each one of that classes, there are several indicators. The problem here is that we have just a small amount of messages for each one of the indicators. So it's hard to generalize using a traditional method. We are trying to apply this meta-learning approach that is largely used for images, but we are trying to apply these methods for text as well. For those in education, we want to somehow measure collaborative learning by using this network that I just showed you, especially the relationship between social and cognitive presence, and also we can include topics here. We are also features to see based on this graph. So propose some learning analytic tool that we can report for teachers based on the results that we have. And also include the teaching presence in this analysis, because so far we are just analyzing students' messages. So we are analyzing social and cognitive presence that are related to the students. But we also want to include teaching presence in this analysis and try to build a better online discussion over the courses. Okay, that's it. I'm open to questions, comments.
Thanks very much, Rafael.